Group 11's final project, the Double H Maze Experiment. Just a quick introduction. On the right, we have a figure showing the Double H Maze, all of the states that provide rewards or punishments, and how to reach each state. We wanted to mimic some animalistic behavior through feeding patterns and through rewards and learning. This was all based on a lab we did previously in the course, the Model-Free Reinforcement Learning Lab. An expansion of that in the sense that our maze included 12 states and 4 available actions. And our robot's going to begin in a stress state, then explore its environment until it accumulates a reward. After accumulating those rewards, it enters a calm state. And then we believe that our robot will learn to go to reward states in order to be calm. Our method for putting together the robot was we wanted to put a distance sensor on the front that forced it to act whenever something came within 10 centimeters of the sensor. And then we had a color sensor facing downwards toward the ground that helped us administer the rewards or the punishments. We used the model-free learning as a template, except we modified the reward system, action selection, and speed regulator. This is a quick video of how we did the trials. All the trials we did had to be consistent, so it was 25 minutes worth of trials for 75 trials. We opted out for using an actual maze and instead wanted to use an open floor plan, and we used the tape to just symbolize our Model H maze. All right, some results. They can be broken up into 3 phases. So trials 1 through 27, we were exploring all the possibilities, the learning outcomes for all the states. From trials 28 to 48, we tended to go towards blank or reward states, but there wasn't a preference for either. There was just a focus on not going towards the punishment states. From trials 49 to 75, we consistently ended our trials at reward states, but the robot preferred to go back to state 0 from states 1 through 4 rather than reach a non-reward state. And there was no preference between states 1 through 4 as shown through the Q table, because from states 1 through 4, you can always reach either a punishment or reward. Just a quick conclusion, we learned that our robot did learn to go in the direction of the states that provide rewards. It did avoid the states that had punishments. It reached a calm state by accumulating a global reward of 4 and therefore slowing down. And we wanted it to mimic the behavior of a hungry or distressed animal, which it did. After acquiring rewards or food, it did calm down, and then it demonstrated the following learning principles. So learning and memory, reward versus punishment, value systems, sensory motor integration, exploration versus exploitation, embodiment, and stress versus calm.